Okay, so good afternoon, everyone. My name is Tony Choi, and welcome to today's webinar. It's hosted by the Municipal Engineers Association Young Professionals Committee, and I'm the moderator for this session. And we're excited to have you join us as we explore an important and innovative municipal infrastructure project. Today's presentation will focus on the Bathurst Street Water Main Replacement Project, a key initiative led by the City of Richmond Hill to enhance the safety, reliability, and resilience of its water distribution system. This project is a great example of strategic asset management in action, aligning with Richmond Hill's asset management plan to ensure public health, safety, and service reliability. From data-driven design assessments to advanced construction techniques like horizontal directional drilling, this initiative showcases best practices in municipal infrastructure development. Compliant with Ontario's Safe Drinking Water Act, the project highlights Richmond Hill's dedication to regulatory excellence, innovation, and sustainability, ensuring that residents have access to a safe and reliable water supply. So today we're honored to have Mohammed Kashani with us today to share his insights into the project's planning, execution, and impact. Mohammed is a seasoned engineer with over 25 years of experience in managing complex municipal infrastructure projects. As manager of design and construction for the City of Richmond Hill, Mohammed leads strategic initiatives, oversees multi-million-dollar capital projects, and champions innovations in service delivery. Holding a master's and bachelor's degrees in civil engineering, he's a licensed professional engineer and also a project management professional. Mohammed's previous roles with the cities of Vaughan and Toronto, alongside international experience, have shared his expertise in infrastructure, design, construction, and regulatory compliance. He is actively engaged in various industry initiatives. He instructs with the Good Roads Association and contributes to the OPS GC Committee for the Municipal Engineers Association and the Ministry of Transportation. Mohammed is committed to fostering growth in young professionals and advancing the engineering profession. He's looking forward to sharing his insights on innovative municipal projects with the attendees today. So given the overwhelming attendance at today's webinar, we ask that you enter your questions in the chat so Mohammed can answer them at the end of his presentation. Without further ado, please join me in welcoming Mohammed. Thank you.
Thank you very much, Tony. Appreciate it. And thank you for the introduction. That was really good. And thank you. Good afternoon, everyone. I'm very pleased to be here and present this presentation that hosted by MEA Young Professionals Committee. My name is Mohammed Kashani, and I'm the manager of design and construction, City of Richmond Hill. And the rest of the stuff Tony mentioned, I better get into the actual presentation. Just to let you know, I timed myself a couple of times, about 35 minutes to 40 minutes. This presentation kind of is in length. I try to speak faster. And also at the end, we are going to have time for Q&A. I put together a quick agenda here for us. That we will go through the City of Richmond Hills and its asset management, and also we go into the detail of the project overview from inception to completion, from initiation, design, and then tendering phase construction. And at the end, we are going to have Q&A. So let's get started. The City of Richmond Hill is committed to delivering exceptional public services. Our strategic plan focuses on three pillars: growing a livable, sustainable community, focusing on people and connections, and strengthening foundational systems. Richmond Hill's balanced approach to supporting the environment and the economy and its people underpin this project. We'll explore how strategic priorities and innovative methods such as trenchless horizontal directional drilling, or for short, I'm going to call it HDD, help delivering the exceptional services to the resident of Richmond Hill. The asset management, our asset management informs capital budget process and prioritizing our investment in general and ensuring the financial sustainability. We manage over 430,000 assets, infrastructure assets like road, water main, sewer, parks, facilities, and many more. These these infrastructure assets deliver critical services, and our approach ensures that these infrastructure remain efficient and cost effective for the resident of Richmond Hill. So particularly for our Bathurst water main replacement program, the best practices of asset management includes conducting comprehensive condition assessment, developing a data-driven strategies based on these condition assessments and the risks, and also considering the service level standard in the decision making and prioritizing replacement based on risk and public safety, using life cycle approaches for planning, and continuously monitoring these updates and strategies to make sure they are relevant. By following these practices, we ensure sustainable and effective water services for everyone. So how we select the project? That's why I just started from inception. I just went a little bit before to tell you how a project starts from high level, from master plan, from the strategic initiative of the city, then into the asset management. And then asset management will help us to pick the project by preparing a project need form, and then also including the project as part of the 10-year capital plan. We prepare 10-year capital plan, and then we go through the securing the approval from council and the budget approval from the council. This process follows Richmond Hill's five-step or five-stage budget strategy, which involves planning, reviewing fees, forecasting capital needs, and approving the budget as a whole. Once the project is approved as part of the capital budget, then it becomes an active project, and it'll come to my team to be delivered. So now we have an approved budget, and although this project has been approved and constructed and everything was done, even we went through the warranty and everything is completed, but I'm just saying this is the typical approach. Going back to Bathurst water main, this project involved replacing approximately 1.8 kilometers of aging metallic water main, including ductile iron and cast iron water main installed back in 1978. At the time that we replaced them, they were 44 years old, and we experienced a lot of breaks in this stretch. And we replaced them with PVC water main to meet city's current standard and MECP Safe Drinking Water Act. This initiative was vital for ensuring the sustainability of city's infrastructure, reducing water main breaks, and minimizing disruptions to residents and businesses due to water main interruptions. Additionally, the project was carefully planned to avoid disturbances to nearby creeks, protected the red side dace habitat, and minimize tree removals and impact within the York region right-of-way. Originally, we had a plan to deliver this project as part of York region widening along Bathurst, but later on, the widening was stopped and was moved out of the 10-year plan. They just decided to widen it from Highway 7 to Major Mac. And this section north of Major Mac, we experienced some water main breaks. So therefore, we delivered it as a standalone water main. Having said that, we had to consider the ultimate widen Bathurst from Major Mac to Elgin Mills, not to have any throwaway costs for the future widening. As a result, we carefully picked the alignment. I will get into more details if you need it. Because I need to just tell you from beginning to the end, I will try to a little bit go fast with the overall process and focus on the process. But really, what we are trying to do when we have a water main replacement in general, This project aimed to provide a water distribution services that support domestic consumption and has sufficient capacity for firefighting purposes. In York region, we have a two-tier municipal government. We have the regional government, which is York region. They look after the trunk main and those big pipes. And then for the local governments like Richmond Hill, City of Vaughan, City of Markham, we mainly look after the distribution lines, the smaller pipes, but the ones that deliver potable water to all the residents. When it comes to the Watermain, there are two conflicting or two balancing sort of factors. One is pressure, another one is capacity. So when you have a bigger pipe, you have more capacity, but then you have to make sure that you have sufficient pressure for firefighting, and you need to balance these two factors. And therefore, you need to have computer modeling because it's a system. It's just not in isolation, only the 2 kilometers. You have to make sure that the modeling gives you the appropriate size. So now that we have this project, how we are going to initiate that? As I mentioned, we are in the city of Richmond Hill, we follow the best practices. And one of the best practices is to follow the PMI or PM. We have a PMO manual in the city of Richmond Hill that we follow that. For instance, one of the aspects of that is to sign the project charter. We don't initiate any project before we get the project charter signed by our upper management, and then within the project charter, we prepare the overall goals and milestones. Once that's signed, then we host an initiation meeting to gather stakeholders' input. Then we develop the terms of reference to for the consultant to obtain the proposal and assign the project to consultants. And then we hold a formal kickoff meeting to introduce the teams and align on a scope and risks and schedules. So that's the project chart. And then during the design, we go through the project management plan. We look after the risk registry, stakeholder management, all these kind of things, which starts from the project charters and goes into the project management plan, and so on and so forth, which I will mention that throughout the presentation. Once the project charter is signed and the kickoff design is initiated, so technically, we are into the preliminary design. And as part of the preliminary design activities, first and foremost, we need to conduct a topographical survey and gather historical engineering drawings. These steps help establishing a foundational understanding of the existing condition and serve as a baseline for future design works to come. The next step is to move into the geotechnical investigation and subsurface utility engineering, or SUE for short. I will refer to that as SUE, to account for soil conditions and underground utilities, which are essential for minimizing risks and guiding the design process effectively. Another vital component of the preliminary design activity is tree inventories. We go through that to find the health of all these trees, and then if we are impacting the trees by removal, trimming, what kind of mitigation measures do we have in place, and in worst case scenario, what would be the compensation plan to address any environmental considerations. Other activities as part of the preliminary would be to gather groundwater monitoring, archaeological assessment, and screening for species at risk. These tasks ensure compliance with environmental and cultural regulations, helping us mitigating risks and prepare appropriate mitigation plans. So once we've done these kind of activities, then we are ready to put together a 30% preliminary design. What entails in preliminary design? We need to look at the potential utility conflicts, adhere to CAD standards, and prepare detailed reports if required. And we also focus on stakeholder management and property clearances and budget allocation and schedule planning to ensure design progresses smoothly. Let me pause here, especially for water main designs. This 30%, in my opinion, is very key, as opposed to rush through the 30% design and get into, I know sometimes we have a deadline and there are pressure to get things done, which we are all cognizant of that, but it's very crucial early on in the design process, like at 30%, to really take a step back and see what would be the best approach for that specific project. For instance, in this case, we could have not done that and say, okay, you know what? The conventional method of construction for water main is open cut. 80% of the project is open cut. Okay, let's go through the open cut. But that would have been a very huge and costly mistake. By adopting HDD, we avoid those ones. How we did that? Because we paused here, we evaluated all the different approaches. And I'm not saying there is a one size fit all, but really we need to look into all the tools in the toolbar to see which one is the best one. In this case, HDD was the best one, and I will explain why. My suggestion is that another key component is a stakeholder review. Another thing that we do as part of the project management plan that we have is that to have a stakeholder management log and take a look at what they are required of us and address that. Because if you have a good handle of the stakeholders' requirements and needs, I'm not talking about their wants. Obviously, sometimes we need to differentiate between the wants and needs, but really the things that they need, we need to address them early on, because that will avoid any rework or complication in the 90%. Because if at 90% you want to address those things, those are going to be very timely and costly for you. So that's another key point. So 30%, take your time to make sure you are doing a proper planning and also engage the stakeholders early on. Then we go into the 60%. And as part of 60%, still you are going to deal with the utilities. And at this point, you will refine the horizontal and vertical alignment. So at 30%, typically it's just you deal with horizontal alignment, but at 60% now you get into the vertical and also QA, QC reviews and resolving any constructability issues. Additionally, we focus on ensuring permits that being at least initiated for permit requirement, addressing any stakeholders' feedback, and ensuring the design schedule aligned with the construction timeline. So now you pass those preliminary, and now you are going to get into more detailed sort of design. I'm talking about geotechnical investigations that they are very important for designing underground pipelines. And so what is part of it is you need to have data for the soil types, for the backfill recommendations and shoring recommendations, and ensuring the safety and compliance with regulations. If you don't have this information as part of your tender, then the contractor won't be able to provide those information. So then you are going to get into either change orders or claims and back and forth. So therefore, it's important to have a reliable geotechnical investigation to provide the necessary information to the contractor, and also for your design to be able to come up with a appropriate design and successful construction. When I talk about different types, we have 4 types based on the OSHA or OHSA regulation. We have type 1, which is a cohesive soil, and get into type 4, which is non-cohesive. So for each of these type of soils, we have a different requirements for shoring that contractor needs to conform to the OSHA regulations. How they can do that? By knowing the different types of soil in your geotechnical investigation. A comprehensive geotechnical report includes borehole data, groundwater monitoring results, and a plan for managing excess soil, which helps ensure the project adherence to environmental standards. If you heard recently, back in 2021 and 2022, now for a few years, we are dealing with amended regulation that requires us to have a excess soil management in place for all the construction projects, which starts from the detailed design. At the detailed design, with the geotechnical investigation, you need to have characterization of soil and have a excess soil management plan in place. So these are all important steps. And trust me, if you don't have this information, especially nowadays, none of the receiving sites are going to accept your soil. So you need to do, if you don't do it during design when you have time, and it's, you can do it with a proper sort of investigation, with a better quality of investigation. You have to do it very costly during construction with change order and a standby time, which you don't want to do that. So after that, subsurface utility, or SUE. SUE involves locating and mapping existing underground utility using various methods, including geophysical and visual analysis. This data is classified into quality levels. There are 4 different quality levels: D, C, B, and A. And quality level A is the highest accuracy through utility locating. At the 30%, we need to do the quality level D, C, and B, which is kind of like utility, identify the utility conflicts. And then once you have that, at the 60%, 90%, then you are going to have the detailed, you are going to have a quality level A SUE, which provides precise data for locations and for construction purposes. Let me find this laser point to show you. Here is, like, you see, you are going to have a test pit and test hole just to exactly verify where is located this utility. If you are planning to have the water main that goes beneath or above, how you are going to plan for that. So by having detailed information and at the 60 and 90%, and SUE level A is the way to go. Once that's done, then the next step as part of your 60, 90% is that you need to obtain permits from TRCA, MNRF, DFO, York Region, you name it, the ones that we require for your specific project. These approvals ensure compliance with regulatory and environmental standards. Then you are ready to wrap up the design at 90% or 100%. That at that stage, when you are finalizing your design, basically you are finalizing your utility relocations, alignment, cross sections, and tender drawings all together. Also at this stage, you have to have your specifications, terms of the schedule of price, and all those details for your agreements. Everything needs to be sorted out. And the more important steps at this point is you have to make sure that the constructability reviews being done, conducted, and you have all the permits in hand. Or if you don't have it, you know that it will be ready soon, at least. So once the design is done, now we are going to go into the tender. But before that, we have another gateway in the city of Richmond Hill. We need to prepare the pre-tender checklist. And that checklist, it will verify that we have all the permits, property clearance, utility relocations, we have the budget approved, and we are ready to go. All the QA, QC being done, and we review all these things, and we sign off on that. And then the next step would be to go through the tender process. The tender process in Richmond Hill being facilitated by our procurement division, and we go and invite the pre-qualified contractors via bids and tenders platform. In Richmond Hill, how we approach procurement is in a two-stage process, let's say. Step one is that we do a pre-qualification. And step two, which is price only, we invite the only pre-qualified contractors to bid. This allows us to just qualify all of our contractors. So we have different categories. We have, like, for instance, for road, for underground work, for electricals, we have different lists of pre-qualified contractors. At the beginning is public, everybody applies, then we will review that. We have a requirement for core certification to make sure they have a pretty good health and safety policy and procedure in place. And then once we qualify them, we typically qualify them for 3 years. And within that 3 years term, we just invite those pre-qualified contractors for the stage 2, which is competitive bidding, low bid only. And then we repeat this cycle. If you have any question, please reach out and I will explain more. Then we get into the construction, which is the phase that we focus on detailed planning and execution to minimize disruption while maintaining safety and efficiency. The key steps include preparing a staging area, securing permits, and setting up traffic control measures. Then the activity begins with a notice of proceed, then to be issued to authorize the contractor to begin the work, and then there will be a pre-construction meeting. The locates needs to be ordered and in hand before any digging, and then submittal for the materials, any shop drawings review, and then at the end, mobilization to allow the contractor to prepare equipment and resources on site. Now, methodology. For the methodology of the water main construction, typically there are two: open cut and trenchless. These are big categories. When it comes to, if I want to numerically tell you what is the percentage, I would say still, especially for the distribution lines I'm talking about, not for the trunk mains, but for the distribution lines, still there are, I would say 80% are open cut. And there's a reason why. And then 20% trenchless. The reason why, if the trenchless is that great, somebody may ask me, Mohammed, if the trenchless is that great, why is not 100%? Because when we have the when we have the distribution line, imagine every 5 meter, 10 meter, you have to have a service to, as a lateral, to go to the houses or residents, businesses. So even if you put the main line as open cut, then you have to go back for every individual connections. You have to dig down and do the connection. So in a way, sort of it defeats the purpose. Having said that, some contractors still, they prefer to do that. And in some cases, we have to do that. And to be honest, it's not open cut versus trenchless. Most cases, we have like a hybrid solution. If you need to go under the creek or something, still you need to do trenchless. So best approach is not black and white, it's just amalgamation of both methods. So now, HDD, for instance, in this case, this is a 3D illustration of the HDD that involves drilling beneath the surfaces to install pipe without extensive excavation. This minimizes disruption to the roads, creeks, utilities, you name it. And it's very effective and efficient. How does it work? We start with a one of these HDD machines like VHDG. I don't know if you saw that. It starts from the pilot bore. There is a pilot bore between 2 to 4 inches pilot bore that they start, and to go through the alignment all the way from entry pit to the exit pit. And then at the end, they put this reamer. They connect the reamer to widen the hole. Let's say if you have a like a 12-inch, 6-inch, 12-inch pipe, you need to put the reamer into the pilot bore goes there, and the reamer needs to widen this hole to allow for the pipe to come in. And sometimes this cycle is not just one go in, one come in. Sometimes they have to repeat this process to have it wide enough to pull the pipe into the hole. And the pipe, the PVC pipe, it can be a fusible PVC, it can be some of those individual PVCs that they connect. For instance, for this one, we had a combination of both. We had fusible PVC and we had TerraBrute from IPEX, which we put together. So that's how it is done. Again, there is another, here is showcase that the pilot bore is being bored underneath of all the utilities, roadway, from one side to another side, and then minimize the disruption to traffic and all those good quality of HDD. So you see the entry pit, exit pit, and these entry pit, exit pits are varies from the size based on the whether you have a fusible PVC. From one hand, that you pull through the pipe, that needs to be big enough to allow for the pipe, especially if you have an individual pipes. These are in 6 meter length, so you need to have enough room to pull through the pipe. Once the pipe is installed, now is the time for testing. We have 2 types of tests: pressure test and disinfection. The test begins during the design phase and continues through construction to ensure compliance with commissioning requirement. Pressure test identifies leaks or weakness in the pipelines, allowing necessary repairs. So what does it mean? Let's say we have to have the maximum pressure from plus 50%, and it has to hold it for 2 hours. Typically, it's 100 psi, the maximum pressure within the pipeline. So we tested for 150 psi, and we put the pressure into the pipe for 2 hours, and it has to hold that water within the allowable leakage. And when I say allowable leakage, to allow for the expansion and all these kind of things for the new PVC pipes. And it has to hold it for 2 hours. There would be a form to sign. And once this test is passed, then we accept this as a system that can hold the pressure, and we move on to the disinfection test. The Watermain disinfection follows the AWWA C651 standard, ensuring water quality and safety. A disinfection plan is submitted and approved before work begins. The method of disinfection, there are 3 major methods: tablet, slot, or continuous feed. To be honest with you, everybody follows continuous feed. And in the city of Richmond Hill, we do continuous feed, which means introducing chlorine with the chlorine goes there and gradually into the flow of the water, disinfect all the apartments, and we have to allow for 24 hours contact. We drain that, and after we drain the pipe, then we have to take the 2 consecutive tests. We send it to lab, and they have to pass the microbiological test. These are all the sort of procedures that we follow the provincial regulation, and we make sure that the drinking water is safe before we commission that. There would be a form like this to fill out, and we make sure that everything is passes. We need to have 2 consecutive passes. If the first one fails, or this, obviously we have to repeat. Even if the first one fails and the second one, even the first one pass, the second one fails, then we go back to repeat this process. And unfortunately, last year we had a tough time for a couple of our projects. We had to repeat that 10 times or 12 times. It happens. Typically after 1 or 2, if they take care of it during the installation, everything goes smoothly. And once you have the 2 consecutive passes, then you are ready to do the final connection, transfer the laterals, and you're good to go. So now I have 2 videos that I would like to show you and wrap up the presentation. This first presentation, this first YouTube videos is for our Bathurst water main. Let me see if this works. Hopefully it works.
At the City of Richmond Hill, we are committed to protecting our natural environment, including trees and native species. When we need to replace aging infrastructure, such as water main pipe that brings safe, clean water to our residents, we use environmentally sustainable ways. For example, when we replaced the water main along Bathurst, we used horizontal directional drilling, reducing the amount of waste being generated and minimizing erosion. We put up fencing around trees in the area to protect them, extending their health and longevity. We installed biodegradable fencing to prevent sediment from running into the creek, and installed catch basin filter cloth to prevent sediment from entering the stormwater system to protect the natural habitat of endangered species. These are just some of the many ways the city is using environmentally sustainable methods to deliver reliable services to the community.
And I have one more. This is another water. So this is the first HDD that we did along Bathurst from along a major Mac from Bathurst to Young. And this is another YouTube video that we published a couple of years ago. So I will play this one as well. Hopefully this is okay. Yes, go ahead.
The City of Richmond Hill is always looking for innovative ways to maintain and repair infrastructure. Did you know Watermain is an underground water pipe that delivers safe and clean water to your home? Richmond Hill manages 640 kilometers of water main that service our neighborhoods. It has plans in place to repair or replace water mains when required. This ensures the reliable supply of water. The water main along Major Mackenzie Drive between Yonge Street and Bathurst Street was installed in the 70s. Due to increasing frequency of repairs, it was determined that 1.6 kilometers of it needed to be replaced. Traditional methods of replacing water mains means traffic congestion and disruption to motorists and pedestrians. Instead, the City of Richmond Hill opted to use a minimal impact trenchless method of installing underground utilities known as horizontal directional drilling. It required less digging and allowed the water main to be installed underneath existing infrastructure, trees, and creeks. Horizontal directional drilling is typically twice as fast, reducing the repairs needed on the road and minimizing traffic congestion. Using HDD also ensured that there was no interruption to power or other services in the area, including to the hospital. This is just one of the ways the City of Richmond Hill is being innovative through the use of modern technology to minimize disruption.
And with that, thank you very much. Now we are ready for questions, but I know that Tony needs to tell you something about the enrollment, if you would like. So I will pass it on to Tony, and thank you very much. And I'm ready for any questions.
All right, well, thank you. Thank you very much, Mohammed, for that insightful presentation. It's always great to see how municipalities like Richmond Hill are using innovative approaches to enhance water infrastructure while prioritizing safety, sustainability, and service reliability. Your detailed breakdown of the Bathurst Street water main replacement project really highlighted the importance of strategic asset management and cutting-edge construction techniques. So before we go to questions, on behalf of the Municipal Engineers Association's YP committee, I would like to take a quick moment to encourage any young professionals in the audience to consider joining this committee. We're always looking for new members who are passionate about municipal engineering, professional development, and networking with like-minded peers. If you're interested in getting involved, there are several ways. I think the easiest way is to go to the MEA website, and under the website, there's a resources tab. So if you search Municipal Engineers Association, and then if you click the website, there's a resources tab. And if you scroll to the bottom of that web page, you'll be able to find like a link for volunteering. So you can click that link and fill in the information. Another way is to reach out. There's two ways, LinkedIn as well. There's an MEA YP Young Professionals Committee's webpage. So if you search that on LinkedIn, you should be able to find it. And if you do have trouble finding that too, you can find me or Melanie on LinkedIn. My face is on LinkedIn, so you can find me. Melanie's there too. And so yeah, we can reach out and hopefully that helps. And yeah, without further ado, let's get to the questions. Thank you.
Okay, thank you very much. I can see there are a few questions and I go just from top to bottom. So the first one is the pre-qualification of contractors for all capital projects or specific to each project. No, this is for all the capital projects. So we pre-qualified contractors for all capital projects that we deliver. Actually, my team delivers all the linear infrastructure, road, water, main, bridge, and also I'm in charge of parks project as well. So we do have a pre-qualified list of contractors for roads, underground, electrical, parks, stormwater management facilities. So we have 6 different pre-qualified lists of contractors for each of them for 3 years. And that applies for all of the capital projects. Sometimes if there is any specific, like for instance, we have a specific bridge that we are building over the CN rail, and our pre-qualified list of contractors, they don't have the quantity. So it's just, I would say maybe 1 or 2%, like very odd number of, like typically, let's say if I have 20, 30 projects per year, one of them might be not qualified for all these lists. So I may need to pre-qualify that individual one separately. But other than that, to answer your question, is for all capital projects. The next question is there a tolerance degree of freedom on HCD alignment? Yes, there is. By design, as part of our specification, we allow about plus minus about a foot in horizontally and vertically to deflect. Just we give that freedom to the contractor. So that's okay. It's written in our specification. But if it is more than that, then we need to review the alignment. And we had actually an obstacle for this project that we hit the concrete block. It was an old concrete block that we didn't have it as part of our as-built drawings, and unfortunately we had to significantly shift locally at that specific location. That was a change order that we had to deal with, but other than that, they managed it within the 1 foot tolerance. So that's that. The next question is, how much did the region influence the design, construction alignment, setback? Yes, that's a good question. Unfortunately, it's anonymous. So hopefully I'm not getting into the trouble. Yes, York Region is our partner. Having said that, since they mentioned, since they have the plan to widen this, so our alignment, right, the existing alignment was within the boulevard, existing boulevard. But because of the widening of Bathurst, then we had to realign it or find a new alignment within the proposed or future boulevard. There are very good reason for it, because there is another question later on about the settlement. We prefer the alignments to be within a boulevard. So if there is any settlement, or actually for the maintenance to access that, if it is within the live traffic, so it becomes an issue. But therefore, the best alignment for these watermains are to start with boulevards or sidewalks. And then if you don't have room, then you go to the other side alignment, the other side boulevard. Then you go to the curb lane, and the worst case scenario is to go to the middle lanes. In this case, since region actually purchased the land for the widening, we were able to go all the way, and they pushed us all the way to edge of the property line, and we found a suitable alignment. But definitely we had to submit our alignment for regions review in order to obtain the MC permit from region. Yes, they had a lot influence on our design, but they worked very collaboratively with us and helped us tremendously to find an alignment. But yes, the timeline with respect to, for instance, we were not allowed to close any lanes during the rush hours. So that limited us tremendously. But since we had the trenchless methodology, and within the boulevard, we had just only trouble for the entry and exit pit, and most of them, we locate that into the boulevard. So that restriction was not that much of a problem for us. The next question is, how do you ensure there is no settlement above the pipe and for directional drilling? So these trenches are like 2 meters deep. And also, I have to tell you, it so depends on the geotechnical investigation. Let's say, for instance, if you have a section that is all granular material, you might not be able to do HDD, because then you will be forced to do a little bit of hybrid approach. But the good news is that this area was silty clay, and we were able to go through it and has passed the warranty period, and we didn't see any settlement for the two HDD projects that we recently did. And in my career back in the city of Toronto and city of Vaughan, I did those. And I would say for majority of projects, we didn't have that many issues with the settlement, especially we managed to put these things in the boulevard. If it is in the road, that would be a different story. But I would go back to the geotechnical investigation. And therefore, that's why HDD has to be selected for a specific type of soils. And the next one is, how would you get clearance on design from MECP? So for instance, in this one, we had a red side days. And we had to demonstrate that we are not negatively impacting the endangered species. And by selecting HDD, we ensure them that we are minimizing the impact. And another thing is, we engage them early on as part of the 30% design. As soon as we figured out what we are trying to do, then we had a early appointment with them to explain through TRCA. So we started with TRCA, and then TRCA recommended that we have to get the MECP, and then we got both TRCA and MECP because of the red side days. The key is just to engage them early on and demonstrate that you are doing your due diligence. They listen to you, and they just really want to make sure that we are doing everything in our power to minimize the impact. And we demonstrated that, and we got everything. I have to tell you, we got all the permits almost at the last minute, but it was all in all came in before we go to tender, and we made it. So it was a process I have to tell you, it took us about 9 months, but since we engaged them early on, we were able to address it. So I'm going to go a little bit quick. Thanks for presentation, no problem. How did you maintain your Watermain cover requirement, notably at the HDD access point? Oh, the cover. So when you have access point, it goes 30 degrees, right? So the 30 degrees, it has to go all the way to reach to the 1.8 to 2.1, depends on where it is. So therefore, the access point that you have, you need to allow for that. So basically, the first 10 meter, 15 meter, it just has to go all the way, and then you need to do a little bit of open cut. Yes, at both ends, you need to do a little bit of open cut. So HDD, basically, you need to go with that 45, and typically it's 30 degrees or 20 degrees. You have to go all the way. So it takes about 10 meters to get to that 2-meter depth. Hopefully that answers your question. How did you decommission the existing water main? Was left in place? And no, we had to section of it. We had to do the grouting. So we had to grout section of it. And some sections, because they were we did a pneumatic with pressure air. We tried to figure out if the metallic water main is in good condition to hold, because you don't want to put a lot of grout, and if there is a crack or something, the grout goes into the sensitive environmental area. So we select this, it was a combination of leave it in place and a little bit of grouting. What is the maximum pipe size for horizontal directional layer? We've done the 400 millimeters. I heard that you can do 600 millimeter. I never done that, but I can comfortably say that typically you can do from 200 millimeter to 400, 200, 300, 400. These are the typical sizes for water main. Okay. And 100 you can do, but then it depends on the situation. But typically we do it up to 400 millimeters. How is soil compacted around the pipe after installation? So there is no compaction. So basically, directional drilling that you have, by making the hole, you put the pipe right there, and it just allows for the pipe to drill in. That's it. And there is no actual compaction around it, except for the both ends and wherever you have your pit or you have the open cut. Oh, Terry, no problem. Is there a diameter limit of water main for HDD drilling, which I mentioned? The next question is, thanks for the presenting that. No problem. Did the city consider rehabilitation the existing water main instead of rebuild? Yes, we consider that. That's a very good question. Did the city consider rehabilitation of the existing water main instead of replacing? Trenchless methodology. Okay, so I teach in OGRA water main courses. It's a 1-week course, and in that 1-week course, I have 1 day to explain in depth the different types of trenchless. If we have, there are 4 different other types of trenchless methodology. There are cement mortar lining, epoxy lining, structural lining, and CIPP, which is cure in place pipe. And for that one, those are great way of doing it. Those are tools in the toolbox. The other 4 types are rehabilitation at the same alignment. HDD is trenchless, similar to the other 4, but is in a new alignment. In this case, we ruled out that opportunity right from get-go because of the widening of Bathurst, York region made it clear to us that we have to find a new alignment for that. And that's why we had to move from the existing one, but that would have been an option. And we've done the CIPP, the first CIPP, we did it last year in city of Richmond Hill on Carville Road, from Bathurst to Young, about 2.2 kilometers. We did CIPP for the first time, and that was a fantastic project, a successful project as well. So because we had to find a new alignment, the rehabilitation was not an option. What is the pipe size difference between city of Richmond Hill and York, 400 or below? Yes, you can say 400 and below is, although we have some of the trunk, we have 600 millimeter as well, but typically that's correct. 400 millimeter and below, they are like distribution side lines that city will take care of, and then 600 millimeter and above, those are trunk mains and force mains. Those are for the York region. That's correct. 450 you mentioned, city and above 450. The new standard sizes is 200, 300, 400, and 600. There we should get get rid of we don't have 250. I know we do have some metallic one, 250, 450, but going forward, 400 is the standard. Do you have experience conflicting with trees and Watermain in a boulevard? What are the required offset between trees and a... So again, yes, in this case, we avoided all those conflicts by doing HDD, but sometimes if you have to have like, let's say a manhole, or if you have like a hydrant or something like that, sometimes we have hydrant. Again, you can try to move them. The key is that the drip line, whatever is above, you have the root beneath it. So you have to stay away from the drip line, and it's going to be very difficult for the open cut. Sometimes we try to do with the hydrovac not to damage the root, just to minimize that. But at the end of the day, sometimes, unfortunately, we have to make the difficult choices, cut down the tree, and then with the compensation plan, plant like 3, 4, 5 more trees instead. But for this project, we didn't have to do that because it was HDD. No problem. Any difficulties with isolating and shutting down portion of the existing? Have you encountered situation, multiple valve? Yes. So the question, let me read it out loud. Any difficulties with isolating and shutting down portion of the existing water main? Have you encountered a situation where you had to shut down multiple valves and had to remodel a few times due to damaged old water main valves? Yes, yes, and yes. Actually, at the southeast corner of Bathurst and Elgin Mills, as soon as we start digging around the existing, because think about, these are old metallic ones. As soon as you start digging beside these water mains, then especially if it is cast iron, and in that area was cast iron, it was just burst. And then you have to go back and fix the existing water main. That was close to the valve. Another time, the valve was not working. We put the key in and the valve is not working because it's old. Although we tried to do the test shot during design, I would say the best thing to avoid this thing, or minimize, you cannot avoid it, is to have your operation do a test shot during design to make sure those valves are operational. And if they are not, you can replace them ahead of your construction or as part of first activities. But yes, these are all, we encounter all these things despite all the efforts. The test shot, they don't go to close it all the way, so they, because they don't want to disturb the, or interrupt the water services to the residents. So they do a test and say, okay, it seems like working, the key works. Then they say it's working, but then when you go to close it all the way, you see that, oh my God, this valve does not hold. And then in that case, you have to go to the next valve, means the area of that you are affecting all of a sudden will double, and then you have to send more notices. So yes, these are all we encountered these ones as part of the project, and all of our Watermain projects, we try to minimize them by ordering a test shot during the design and working collaboratively with our operation team. Due to the impact, the next question, due to the impact on traffic, did you, your group do traffic modeling for the project? Some cases, yes, in some cases, but for this particular one, we didn't do that. And to be honest with you, in Richmond Hill, I haven't done that. I've done that back in Toronto when we closed intersection, right, in Toronto. I closed, let's say, King and Spadina back in 2011 or 2012. I closed that intersection, imagine. So we had to remodel all the traffic in the area to make sure and add more green light. For this particular one, because we knew we are not gonna, and we have to stay out of the rush hours from 9 to 3 o'clock. So it wasn't required, but in some cases, especially if you have closure, like lane closure, maybe, but if you have a full closure, definitely you need to see the effect to the adjacent streets. And I would say, like, I know in Toronto, we had to add 5 seconds green light to this intersection, because let's say if you close Bathurst and then the next road becomes like your new Bathurst. So imagine those roads being handled just for, like, they've been designed to handle the local traffic, and now all of a sudden you put all the arterial traffic through there. So maybe the north-south needs to have additional green. Those things, yes, that's a good idea if required. We didn't need to do that. That's a good question. What tip would you give to municipal engineer project manager to ensure contractor consultant deliver on time? So obviously we need to, in my opinion, so consultant to deliver on time, again, you need to have a very good terms of reference. You need to specifically mention what you need them to do. Like, don't surprise them with additional work. And we need to really be reasonable. Like, for instance, for this one, we allowed for 2-year design because we knew that with 1-year design, we won't be able to make it. So that you have to be reasonable, give them enough time. At the same time, try to work on your terms of reference to specifically mention what you need from them. And for the contractor, also, you need to really sit down and go through the production rate. So, okay, the production rate, if I have that, typically, for instance, let me give you an example. When I did the intersection for Toronto at, which one I have to tell you? Okay, Dundas and Spadina was closed. I had 2 weeks of closure of there. I had to replace, also as part of the TTC track, I have to replace the water main there. Only I had about 24-meter water main. What would be the best production rate in that area? My production rate at that one, although I assumed 1 pipe per day, which was 6 meters per day, I thought, oh, I'm pretty safe. The actual production rate over there was half a pipe per day, right? Then I moved to your region. Now here we do the production rate that we have here. I've done the 20 pipes per day in one of my projects in City of Vaughan. Richmond Hill, like we can assume 10 pipes per day. For the HDD, you can do the pole in 1 week. You can do, in the best case scenario, you can do 200 meters. So it so depends on the condition of the location that you have. So therefore, you cannot just say, okay, my calculation is I'm going to go average let's say 4 pipes per day, 24 meter. So that is not realistic. You have to do your calculation to make sure, because think about it, contractors, they don't assume the risk. They price it for you. And sometimes you say, okay, yeah, put 2 crews, 3 crews. Sometimes it's not doable. So you have to make sure that what you are asking for is doable. So you have to do your homework. And when you do that, then pretty much after that, you need to enforce it and have regular meetings. If you need to have the meeting, when I had the intersection closure, I had a daily meeting, and every day we had touch point, and we had hourly schedule. I'm not saying that was extreme, but in Richmond Hill we have a bi-weekly meetings, and every bi-weekly we say, okay, what you've done in the last 2 weeks, what is your plan for the next 2 weeks, and we compare that against the baseline, the schedule that they submitted at the tender process stage. So I'm going to go to a few more questions here. Water main disinfection typically requires swabbing the pipe before chemical disinfection. I don't think this was mentioned in the presentation. Yes, swabbing for HDD. Yes, we have to do the swabbing. That's correct. I just rolled it up a bit to go fast, but yes, swabbing is required. Basically, what you do, first you do the pressure test. Once the pressure test is done, then you do the swabbing. And then once the swabbing, and you may need to sort of repeat the swabbing a couple of times, and you need to put 2 swabs, and 2 swabs comes the other side, and you look at it, is it, and some contractors, they say 1 set of swabbing is good. Some contractors, they say, no, I need my swab to be clean. Technically, this is part of their disinfection program, but swabbing is very important to make sure that reduce the risk for the disinfection test. Once the swab coming from the other end clean, then you that's one of the signs that you are going to pass quickly. Thank you for mentioning that. How do you drain chlorine water from the installed HDD pipe after disinfection? So you have to flush it. So obviously, one side is connected, and you have like a bypass that is connected with a one-way valve, and the pressure is built into it. So you keep the 24 hours contact, and then you have to flush it. Actually, in this area, which we were, some of it was close to the environmental sensitive area. If we had like a box for the dechlorinated, they have to dechlorinate, and then they have to put it into the SANI. You are not allowed to put it in the store. Therefore, you have to have a plan in place as part of your commissioning plan. But yes, you have to disinfect the pipe and then dechlorine that and put it into the sanitary sewer. How you compare HDD in City of Toronto versus Richmond Hill, cost, stakeholder issues. Again, there are different reasons, and obviously in City of Toronto, because of a lot of conflicts and the access and everything else, the price is higher. Richmond Hill is slightly lower, but it so depends on the situation. You cannot just sit. This is a very generic question, but stakeholder issues. I'm enjoying more Richmond Hill than Toronto, although Toronto, I learned a lot, but yes, a lot of different stakeholders. You have to have a bigger plan when you, and it so depend on the situation. You cannot just, like my experience was in the downtown Toronto, which you don't have room, and sometimes HDD is not even possible because you don't have a setup just to have to go back like 10 meters to put the pipe in. So you will be forced to do open cut. Sometimes you have to do, so it depends on the situation, but I would say generally speaking, the cost is higher in Toronto, in downtown Toronto, and stakeholder issues, I would say more or less they are the same. Okay, another one. In your assessment of HDD versus open cut, what was the cost discrepancy between the two options? I would say they are the same. They are the same. For the installation, it might be higher, but then you are going to save the cost for the restoration. So at the end of the day, the cost, I would say they are comparable. Having said that, the HDD is faster. The HDD is faster. So the thing is, you are going to save time and money on the restoration, but then the installation might be a slightly costly. So at the end of the day, I would say they are the same. So roughly, if I if for my high level estimation, when I do all these estimation at a very high level, I allow for about, let's say, 2.5 million. Now it's around 3 million per kilometers, something like that, all in. But don't quote me on that. You need to do your exercise because you said generally mention that. Okay, so that's that. The next question. Oh, thank you. Somebody says I'm very knowledgeable. No, I'm learning it still. What is the maximum length for 400 PVC you can do? Oh, the stretch, how much you can pull. 250 meter, 300 meter, which is actually, it's very interesting. They line it up for the manhole to manhole. Typically, we do have manhole to manhole about 300 meters. Or sometimes you have to have it less than that because you have, let's say, for instance, you have side connections or anything like that. So therefore, you have 250 to 300 meter manhole to manhole, and that's perfect. Basically, what is going to happen, you turn your exit pit, entry pit into your sort of use that and make it as your the manhole, locate for the manhole, which you have to do it open cut. So I would say the answer is about 250, between 200 to 300 max. Thank you for to my knowledge. Other municipalities in your region introduce program to replace fragile ductile iron and aging asbestos water main on a large scale for all distribution system. The city of Richmond Hill similar programs street by state are they? Yes, we are looking into that. We do have a list of, we have 84 kilometers of ductile of metallic and asbestos. So we are planning to do that, and we are chipping at it. Every year we do 4-5 kilometers, and this year actually our asset management looking into that to come up with a robust sort of. But we do that as part of our asset management in general, and we do that based on the condition assessment and break rates. Because with the financial pressure, we cannot just look at the metallic water main replacement in silo. We need to look into that with all the other needs of the city. That's why asset management come in play, to look at a replacement of water main alongside with everything else. So that's why, yes, there is one, and we are tracking all these things, but we feed that finding and that condition assessment into the EAM, we call it enterprise asset management, and then it will spit out prioritized list of program. But generally speaking, we chip at that 80 kilometers about 4 or 5 kilometers per year. Just hopefully within 20 years we will be done. So that's the plan. But that's a good idea too, because ductile iron and cast iron, their life expectancy, although they say 80 years, but it's about like 60. After 60 years, they start cracking. So ductile is slightly better than cast, but really cast iron 60 years. Although I have replaced cast iron from 1897. 1897, I replaced one at Bathurst and Dundas. So that was one of the old Watermain that we replaced. So some of these Watermains, they last over 100 years. So it so depends on the soil condition as well, and corrosion rate and all these kind of things. So it depends. But nowadays, after 60 years, you have to watch for it. What method was used to abandon the existing Watermain? As I explained, was grout, and we left some in place because the condition of the Watermain was not good to grout it. But grouting was the primary way of abandoning the existing Watermain. What is the allowable vertical and tolerance for the pilot bore ultimate one? As I mentioned, about a foot, that's the allowable range. But sometimes if you, let's say, all of a sudden you have a big boulder or something, or if you had, like, in this case, we had a old structure left in place, a caisson for the culvert that they did not abandon it properly. Then we had to go around that. So if you have those kind of situations, that's a different story. We have to redesign. But typically about a foot, horizontally, vertically, is okay. Oh, how they change it? They have monitored. These machines are very sophisticated and getting better and better every year. So the machine is such a way that somebody goes with a radar, and they go on top of the ground, and they track the head. They track the head, and there is a video that you can see how the head is going with the camera in, and they can maneuver. So a good operator will be able to exactly trace, and before they go and do the pilot bore, they do test pits all along every 100 meter, 50 meter in some cases, to make sure they clear all the utilities. Although we do the utility investigation, we put it in the profile and everything else, but they do their due diligence, they do the test pits and everything else, although you have to mention it in the spec, otherwise you have to pay for it. And then once you have all those, then with the operator, with the camera and everything, they follow, and on the ground somebody follow, tracking all the head, and then when they reach any obstacles, they can a little bit maneuver. I think that's your question. Hopefully I answered it. Is there class EA process requirement for HD? This particular one, because we are replacing the existing, they're asking if EA required. This one is A+ according to EA. So we don't need to do a separate EA, because we are just replacing, we are just maintaining the level of service by replacing. If you are introducing a new Watermain widening, so therefore this was technically is a class EA, but A+, which means exempt from the formal process. Not is because of the HDD, it's because we are replacing an existing infrastructure. The next question. Oh, this is the last question. How deep the radar can accurately monitor the depth from the surface. So the Watermain that we have typically is around 2 meters deep. And for that is, I don't know, but based on what I've seen, for that depth, it's pretty good. When you are going to go under the, for instance, a creek, that's a different story. I don't think they can follow the radar but for 2 meter to 3 meter range, which is a typical depth, it's okay, and they can monitor that. What would be the actual depth? I don't know. Hopefully I answered that. And that was the last question. So thank you very much, everyone. If there's no other questions.
Yeah, it looks like you've answered everyone's questions. Thank you, Mohammed. It's like an encyclopedia. So,
Thank you.
so yeah, no, I think that's about it. Yeah, thank you, everyone. Thank you. So I guess that's about it. Well, good afternoon, everyone. Bye for now.
Bye.